Hi, and welcome to the 8th section of this course, Deep Neural Networks. In this section, we will be reviewing one of the most state-of-the-art and most prolifically studied fields in machine learning, deep neural networks. The section will demonstrate the following topics: AlexNet, Inception v3, Residual Networks, ResNet, Painting with Style, VGG Style Transfer, Convergency Test. Now, we will see the first video of Section 8, Deep Neural Network Definition and Architectures Through Time. In this video, we will learn about the definition of deep neural networks and its architecture. This is an area which is experiencing a blast on news techniques, and every day we hear of successful experiments applying DNN in solving new problems, for example, in computer vision, autonomous car driving, speech and text understanding, and so on. In the previous sections, we were using techniques that can be related with DNN, especially in the one covering convolutional neural network. For practical reasons, we will be referring to deep learning and deep neural networks to architectures where the number of layers is significantly superior to a couple of similar layers. We will be referring to the neural network architectures with like tens of layer or combinations of complex constructs. Deep network architectures through time. In this section, we will be reviewing the milestone architectures that appeared throughout the history of deep learning, starting with LeNet 5. LeNet 5. The field of neural networks had been quite silent during the 1980s and the 1990s. There were some efforts, but the architectures were quite simple, and a big machine power was needed to try more complex approaches. Around 1998, in Bell's labs, during research around the classification of handwritten check digits, Ian LeCun started a new trend implementing the basis of what is considered deep learning, the convolutional neural networks, which we've already studied in Section 5, simple feed-forward neural networks. In those years, SVM and other much more rigorously defined techniques were used to tackle those kinds of problems, but the fundamental paper on CNN shows that neural networks could have a comparable or better performance compared to the then state-of-the-art methods. Nice! We've successfully learned about deep neural network definition and architectures through time.